Okay, so this is the Chapter 5 test review. This will be for the first page. Number 1, it wants us to list other ways that you can write the expression. And it tells you radical form and simplified form. Radical form you can actually write in multiple ways. We know that the top number in our power is the power, and the bottom number is the root. And I know there's other index and all kinds of stuff that the book uses, but I just like to think that the top number is the power we're going to take it to, the bottom number is the root we're going to take it to. So I know I'm going to square root 25. I do the root first because that gives you a nice small number, and then you take it to the power of 3. Okay? You could have also written it in radical form where you had square root of 25 to the 3rd power. That's still correct. Either way. Okay? Those mean the same thing. But I do the root first, so the square root of 25 is 5. And then if I take 5 and I cube it, I get 125. So that is 25 to the 3/2 simplified is 125. And then one of these two answers here is your radical form. Okay? Then we need to do the same thing to 81 to the 3/4 power. Okay? The 4 being on the bottom of the power is the root. So I know I have the 4th root of 81, and I'm going to take it to the power of 3. So that's one way to write it, or you could have written it as 4th root of 81 to the 3rd. But it's easier to take the 4th root of 81, and you get 3, and then taking 3 and cube it is 27. Okay. So for number 2, it wants us to solve the following equation, and we need to check for those extraneous solutions. So for the solutions that we mathematically get, but they don't actually work in the problem. So we're going to start with number 2. To be able to get rid of that radical so we can solve for x, we have to first get the radical by itself on the left side. So I am going to add x to both sides. So I get square root of 24 minus 2x is going to equal x. Now I have the radical by itself, so I can square both sides. If I square the left side, I just get 24 minus 2x. If I square the right side, I get x squared. Okay? So to continue solving for x, I have an x squared and an x and a constant. So I know I'm going to have a quadratic. So I'm going to move everything to the side where my x squared is. So I'm going to add 2x and subtract 24. So I add 2x, subtract 24. And this is factorable. If it wasn't, I could do the quadratic formula. But it is factorable, so I know that it has to multiply to negative 24. So one of them's positive, one of them's negative. And then they have to add up to 2. So it's going to be a positive 6, negative 4. That multiplies to a negative 24, adds up to a positive 2. If you set each of those parentheses equal to 0, you're going to get that you get x is a positive 4 and a negative 6. And before I say, okay, I'm done, I need to check those answers. So I'm going to do a little check here. So if I were to plug in my calculator, let's do, let me do x is 4 first. So square root of 24 minus 2x, but instead of x, we just said x is 4. Minus 4, does it equal 0 is the question. Well, I do get 0 equals 0. So 4 works out. So let's check x equals negative 6. So if I square root 24 minus 2 times negative 6 minus negative 6, does it equal 0? And I actually end up getting the answer of 12 equals 0. So that's not a solution. Okay, so this is extraneous. 4 is our solution. All right, so for the second problem here, draw a little line because I went a little too far. Move over a little bit maybe. we have 2x to the 2/3 equals 8. And I need to get what's taken to the root or the power by itself first. So I need to get this part by itself. So I need to get rid of that 2. So I'm going to divide both sides by 2. And I get x to the 2/3 equals 4. All right, and to get rid of the 2/3 power, I flip the power and take it to both sides. So I'm going to take everything to the 3/2 power, but it's kind of messy writing it on that side. So if I take that to the 3/2 power, my powers cancel to being power of 1, but I have to take this one to that 3/2 power. So remember, that is the same thing as saying I have the square root of 4, and I'm going to cube it. Okay, square root of 4 is 2, and 2 cubed is 8. Okay, so we do need to check to make sure that works, because if it doesn't, then I have no solution. If all of my solutions are extraneous, then I have no solution. But, oops, I lost that. So let's plug in 2 times 8 to the 2/3 equals 8. And I do end up getting 8 on the left side, 8 on the right side, and that does work out. So x being 8 is our solution. Okay, so on number 3, I want you to take your time, and I want you to graph these either using Desmos or your graphing calculator. And we just want the domain, so how far left and how far right do these graphs go? There's no easy way for me to flip this so you can see my graphing calculator or Desmos, and so I have graphed them on those, and I will put the domain, but I just want you to check your answer with what I'm putting, so you do need to make sure you can do this for the test. So, an x cubed graph would look like that, okay? So it goes forever left and forever right. So -infinity to infinity, we're all real numbers. Remember, the square root graph looks like this, starts at 0, 0, and goes to the right, kind of looks like an eyebrow. So it starts at 0, so it includes 0, but then goes to the left forever, okay? So the f of x equals the square root of x plus 3 looks the same, except this tells us it moved left 3. So instead of being at 0, it's going to start at -3 and go to infinity. And then 1 over x plus 2 is one of our functions that we've currently been working on in chapter 7. So it has it's a hyperbola, and it goes from -infinity to where x is -2. It does not equal -2 because there's an asymptote there. But then at -2 on the other side, it also then goes to infinity. So it's all real numbers except -2. And if you were to graph the x over square root of x plus 3, you will see that it starts at -3, or has an asymptote there, but then goes to infinity. Okay, it's not a full hyperbola. It does not have the left side. And then the 5th root of x minus 4, it's long ways. It's kind of something along those lines, but obviously prettier than that. So it's going to go -infinity to infinity. Okay, if you graph them, you can see those. Just make sure, even though it looks like it's flattening out, if it's one that you know does not have a hyperbola, then, an asymptote, like our hyperbolas, then you do need to make sure it's infinity, not stopping at a number, because it does keep going. It just looks like it doesn't. All right, so number 4 says, given the graph of f of x, what test would you use to determine if the inverse of that function is also a function? So we would use what's called the horizontal line test. Okay, and then if we want to draw an example that will have an inverse that is a function, then we need to draw a graph that would pass the horizontal line test, which would say if I draw a horizontal line, it can only touch the graph once. So there's lots of different answers for this, but a straight line would work. If I were to draw a horizontal line anywhere on here, it's only going to ever touch it once. A lot of undoing there to get rid of that. Oops. And so this one, inverse is a function. And then if I want to draw one where the inverse is not a function, I want to draw one where if I draw a horizontal line, it touches it at more than once. Well, our quadratics would touch a horizontal line more than once. So this one, the inverse is not a function. Okay? Now there were lots of options for these, okay? Excuse me. All right. And then for number 5, it wants us to simplify these two. All right, so if we look at 8 times the third root of 2 minus 4, third root of 2, we want to do that subtraction there. Now, the third root of 2 is the same in both terms, so we can think of it as like x. So it's like 8x minus 4x. Well, that'd give me 4x. And we're just going to leave the 3 radical 2 in its place, because remember, it's just like adding or subtracting x. So 8 minus 4 is 4, and then they both have the term 3 square root of 2 there. So that is as simplified as we're going to make it. Now, the second one here, where it has the fourth root of 1,792 divided by the fourth root of 7, if you were to take the fourth root of both of those things, they're very sloppy, you get decimals. So since they are both a fourth root, I can take the fourth root and I can do that division inside of it. So that is the same thing as saying the fourth root of 256, and that equals 4. And then it doesn't have me deal with decimals and stuff. Okay, so this was the first page of the review, and I will make another video for the second and third page.